Coffee in hand. Unit testing. Mudlet. Why you should do it. Um, First of all, hello. Anybody who might happen to be here watching this later. Um, I thought I'd put together a little stream on why it is you might want to unit test your scripts in Mudlet, what it is you stand to gain from doing so, and how it is you get started, since I dropped a unit testing thing on Mudlet recently. So, first thing is, what is unit testing? Unit testing is writing code that makes sure your code has its intended effect. By which I mean, if you're writing a method, say, to modify text, let's say you're trying to create a string that is of a certain width, ftext is good for that. Except up until recently, and I didn't realize it, ftext was not properly formatting left and right aligned text. It was instead returning something that was one space too short, and it turns out it's really hard to see one space in a long line. But unit testing can catch that quite easily in a lot of ways, because it doesn't care what it actually looks like, and it can't be fooled visually. So I was actually writing some example unit tests against a library that I thought would work perfectly and be easy to write tests for, when I discovered what I consider to be a major bug in a library that I've been giving to people for months, if not years, in its original form, to format their text for Mudlet. And that's not, that's not kosher. Shouldn't do that to people. So in a lot of ways, it made me feel good about having spent some time making the unit testing stuff work with Mudlet. Now, this was also in amongst me finding out that we had done some testing work with Mudlet, but it uses Busted, which can be difficult to install for people. So I went and made Lua unit work for Mudlet. What are you? I don't know what you're trying to do, but go away for now. That was some other testing I was doing. Alright. So here, we've run a couple of unit tests. I've already pre-written them. But what it lets me do is prove that it behaves in certain ways. So, and I'm just kind of flying through things here for the moment, just to give a general overview of what, why, and how, and then I'll get into some more specifics. So what it is the ability to test your code and make sure it works the way you think it does, which sounds very simple, but can be complex for some people and can be difficult to kind of wrap your brain around sometimes. Generally with unit testing, especially in the style of unit testing presented here, what you're going to do is you're going to make an assertion. You're going to write a statement that says this is true, this is the way it should be. For instance, for this very first test here, what we do is we write the expected result. We know that this is what it should be, right? Because that's what we want it to be at the end. Then we get the actual result by running it through the method. Then we compare them, and what this method does is it makes sure that this matches, and if it does, that test passes. If it doesn't, it creates a message. So for instance, if we changed it so that it no longer passes, and rerun it, you'll get this output instead. It tells you which test failed, what file it came out of, so we can even go to line 8 in that right here, and it tells us that this is the test that failed. So now we know that for some reason the actual text and the expected text weren't the same. The testing goes even further and tells you what you expected and what you got. So this makes it really easy, especially in the context of making changes to an existing piece of software or an existing library such as ftext, to make sure that you didn't somehow accidentally mess up existing functionality. It keeps you from accidentally moving backwards, which can be incredibly helpful. And as you see, when I fix the test, I run it again, everything goes back to green. So the point behind testing is to make sure that your stuff works the way you expect it to. It's also to make sure that your stuff keeps working the way you expect it to and doesn't suddenly start working in odd ways even though you didn't think you changed anything to do with that. So now I can make changes in ftext, and I know that I already have these 16 tests to prove that it still works the way I think it should. Anytime I make a test, I can run this, and whatever I change, I know that if those 16 tests come back okay, the basic ftext functionality is working as expected. So whatever I wrote didn't break something. The other thing it lets you do is you can describe the code you are about to write with a test. This lets you write the test, then write the code to make the test pass. And in a lot of ways, this is a good practice because it means that not only do you already have a test for the code that you're writing, but it forces you to stop and think about what the code is supposed to do, what it is you're actually feeding the function, and what it is you expect to come back out of it before you write the function. It results in a lot less wasted effort, and it sort of shapes your thoughts around what it is you're doing before you actually start writing it, which can be a major help. So that's sort of the overview of what unit testing is and a basic explanation as to why it is you might want to do it, with sort of a flyby whirlwind. This is what it looks like. I'm going to let the stream catch up for just a second, and see if there are any questions so far, because I realize that I'm kind of plowing through things. The cutest little helper has arrived, so hopefully that won't be a thing. But just so you know, the cutest little helper in the world is here. We'll see if Arlo is an attentive student. Alright, looks like it's caught up. I'm not seeing any questions as yet. So moving along, let's take a look at some of the actual tests. For instance, since I have existing tests here, the most common assertion you're going to use is assert equals. With the package I have installed, which is the one I made available on the forum, you install this and it installs the framework as lum. So that's everything that you have in lum. Turns out to be kind of a lot. The main things that you're going to end up using are assert equals, which just says that this thing is equal to that thing. For tables, it will do a deep comparison of the table. So in a lot of ways, it works. Oh, hold on. Finally, I see the question. Sorry about that, guys. A basic example with some... Sure. Sure. So, let's make a new script. I'll make a test table. So when you run lum, it scans through the global table for tables that start with the word test, and then scans those tables for functions that begin with the word test. So you want to name the table test something, in this case test new func, because I'm going to test a new function. And then you write the function itself. So function and so alright, let me just double check my syntax because I've been doing a lot of yep. Just make the data equals right on. So that writes the test. This line here runs the tests. And now if I save it, they should both fail with errors because there is no my new func. So I've written the tests. The tests have come back red. And then you write the function. So now we save it. Oh. Really? Oh. Right, because it helps if you define it before you define the thing that calls it. I'm running on low coffee today, guys. Sorry about that. There we go. Now it runs. So the basics of a test are make a table, make sure the table starts with test. Make functions for the table, make sure those functions start with the word test. And then it will run the actual test when you do this. Now, lum.luaunit.run is equivalent of running the Lua unit from the command line. Then you put the command line arguments as your arguments to the function. So in this case, I'm passing the pattern new func, so it only runs the new func tests. If I did just that, it's going to run all the tests from all the various test suites that I've written. So you see it jumps from 2 tests to 18 tests. Because now it's not just running those tests, it's also running the 16 tests that I have for ftext. So not super practical, but a small test that shows how it could work. I'm not so good at coming up with practical things on the spot is the problem. Was that was that good, or do you have? Is there something you'd like me to show you more specific? Trying not to have too much dead here air here, but I know that it's several seconds behind me, so. And I moved on too soon before. All right, cool. Um, so yeah, that's a very basic unit test to test one function, and it doesn't quite show its value with something like that per se, but it does show you that it can be easy, and you can, because now if I change the function to, you know, I flip my logic for some reason. First, I teach myself how to type again, but now when I save it, it doesn't pass. And it tells me which doesn't pass. Expected true, actual false. Because I flipped my logic. Now, I don't know why I would do that, but... Well, actually, I do know why I would do that, because I re-architectured whatever it is I was calling this function from. But, um... the point is, if I change something and it breaks the tests, it helps me catch it, which is the main point of the tests. Uh, unless you're doing test-driven design, which is where you write the test first. Now, there is value to writing the test first, as I said, because it will tell you in advance what it is you're actually doing. A lot of people sit down to write code and they just start writing code without actually knowing exactly what it is they're trying to have the code accomplish. And writing the tests can firm up in your mind what it is you're trying to do before you actually try and do it. Now, I've used Lua Unit in particular because it is a fairly simple library that can be imported in only one file in normal Lua, which made it particularly easy to adjust for use in Mudlet. There are a lot of assertions. There is the basic assert equals, which tests two items. Now, it doesn't test if they're the same object. Like if table A equals table B, it fails because they're not the same object, even if they have the same items. This is more like this is a deep comparison, like our underscore comp function does. So, as you can see here, the tables must have the same keys, they must have the same number of elements, and each key must have the same value. Assert not equals is the flip of that. If they are equal, it will fail. Then you've got a whole list of truthy ones. I recommend assert true and assert false, because they will test if it is actually true or actually false. This is wrong. That will actually fail. I don't know why they have that there. I've tested it. Because you're the one writing the code, and you get to decide if it returns true or false. You don't have to test if it's truthy or not. Just return true if you mean true, and false if you mean false. The only other time that I would use something else is if I was checking something that had the nil plus message pattern for a failed action. Then you could test if it was not false, or not nil. So, but really, if you're writing your own code, be specific in your code. If you mean true, return true, and if you're testing for something else, test that it actually responds with that something else. If you know you're expecting a string, don't just test if it's not false, or what is the test called in this one? Eval to true. You want your test to be as specific as possible, is what I'm trying to say, with a little bit less stuttering. You want to make your test as specific as possible because that way you get more specific information when something breaks. So the more specific you can make your tests, the better your tests will serve you when they actually come into play. Uh, Also, you can write multiple assertions per test. So here I just had one assertion per test, but over here you'll notice that I have two assertions per for most of the tests. I assert that not only is the text what I expect it to be, but that the length is the length I expect it to be, just to make sure I didn't mess up when I was writing the expected value, because again, those are hard-coded values. So that is a place for human error, and writing as many tests as I can to make sure that I haven't somehow screwed up on both ends of it is preferable. Uh, I recognize that I am a little bit rambly this morning. This was a little bit of a spur of the moment stream idea. So I am hoping at this point to open it up to questions while I think about anything else I might demonstrate in a sort of quick and easy manner. Otherwise, this might be a fairly short stream with only a couple of people even here. So I may do a more collected thoughts video on streaming and how to do it later, but I'm not good at all of this. I'm a coder, not a presenter. The most adorable presentation helper is not a very good helper, though. Uh, so this is another place where I expect to beat the "you should put it in a function" drum. You can't really. I mean, you can write a test in a trigger or alias to test the function that you were about to write, but there's no real good way to test fire a trigger and have that return in a pure Lua context. So the way to do that would be to write a function that does the functionality of what the trigger is supposed to do, and then test the function. Uh, I have considered trying to write a mock framework around functions and the like, and adding assertions for assert matches and stuff like that to triggers. But um, at the moment, there's not really a good way to hook into that via the Lua. So this is another place where this is a reason why I say it's best to put everything in a function and then call the function from other places, because you can easily test a function. You cannot easily test a trigger per se. You can test what the trigger is supposed to do, and you can use feed triggers to see if the trigger matches. But you can't really it. The trigger itself isn't callable as a function, so far as I'm aware. Now, if the trigger were made available to be called as a function or requirable from inside of Lua code, then you could probably actually make that work in a way. Um, but it's very it's I have not yet found a way to hook into trigger execution for testing, like assert if the trigger name was like my trigger. I guess I'm horrible at this. If the trigger name was my trigger, then I don't know of a good way to check the code in my trigger without it being in a function already. So if you define a function in your trigger, you can test the function that's defined in the trigger. But this is the unit testing is really meant to be at the code level. Uh, you know, you use Lua to test the Lua. Does that make sense? I'm rambling a little bit again. Sorry about the child. was a child. Making the noise. I got so much dead air. I'm sorry, guys. I should have put more thought into this, but I wanted to try and get something out there. I also hadn't expected him to wake up so early. He's usually still napping now. So yeah, the other thing to come out of this is even more reason to put everything into a function so that you can test what the function does. I try and keep the use of code and triggers and aliases to a minimum. I put all of my test code in an alias because that provided a nice, easy way to do full setup and teardown and see the results of everything. And I'm on the fence about that. Part of me wants to put the code in with the rest of the code, except that I can't always guarantee that anybody who imports my ftext package is going to have the unit test package. So I think I'm going to continue to write my own test as a separate alias and import that alias to do the testing. But if you're writing code just for yourself, there's no reason not to put the code that tests it right next to the code that does the thing. Except, put it in a function so that you don't run the test every time you load your thing. Because right now, as written, every time I load this up, it's going to run this. So you're always going to have that ran to test bit. But that's it, man. And woman, and or child, I guess. Uh, that's really the basics of what it is and why you should do it. It helps you catch your own errors. It helps you think through what it is you're trying to do before you do it. And it sounds like my little mister is becoming a little bit more demanding of attention. So, is there any more questions? If there's no more questions, I'll go ahead and wrap it up here and let this save itself up to YouTube, and we'll maybe do a follow-up video if people have questions after they've watched this. So, uh, hopefully that wasn't too rambly. Oh, I only just noticed it tells me how many tests I told it not to run. That's kind of cool. Anyways, alright, I'm going to go ahead and shut this down if I don't see anything in the next, say, 2 minutes. I think most YouTubers actually clap to sync things up, but since I'm not trying to sync video and audio. Next time, I also hope to have some music playing in the background, but I didn't get around to actually setting that up first. I think that would help with some of the dead air and help cover up the clicky clacks. Alright, I'm going to go ahead and shut it down, I think. I'll be available on the Mudlet Discord, as always, for any questions that you might have about using Lua Unit for Mudlet. I am more than happy to help people get their unit testing started and off the ground and help them write their first tests. I am Demonic on Mudlet Discord, as always. Everybody, have a good weekend. Stay safe out there with the current crisis, and happy mudding.